Hello guys, welcome to my channel osgroup-techies. So today we are going to talk on containers and virtual machines. So we are going to understand what actually containers are, and also before understanding what containers are, we are going to look on what is a virtual machine, and then when you go to containers we have a better understanding. So before virtual machines we have an operating system. So operating system is when you see a big picture of an operating system, it is all about files and processes, and so it is also an low level software which controls your hardware and actually helps you get your task done with the least of friction. Talking about virtual machines, let's talk about the problem before virtual machines. Before, what we had a one-to-one mapping of your hardware, which includes CPU, memory, and NICs and other devices to an operating system. And until unless virtualization came into picture, we have, in case we had to have different set of if we want to experience different set of operating system, we had to have a different hardware altogether, and it was creating a problem of underutilization. For example, if we have some hardware, very heavy hardware, which has one operating system and it is bound to single operating system, single hardware, then you face that problem of underutilizations, right? So to solve that problem, the concept of virtual machines came into picture. Not only to that problem, there are many other problems it solves. So virtual machine is the main concept behind is to abstract the hardware of a single computer into several execution environment, thereby creating an illusion that each separate environment is running its own private computer. So this was the main purpose. If you see the diagram over here, so virtualization is achieved by a software by a software called hypervisors. So there are two types of hypervisors. One is type 1 hypervisor that directly sits on top of your hardware, and another is type 2 hypervisors. So these are two type of hypervisors which helps you to provide the capability of virtual machines. So as you can see, virtual machine is like it is like a separate execution environment, and it will actually it will give you a look and feel of a same as your one single-handed virtual operating system with an hardware, right? So this is what virtual machine is, and these are the examples. VirtualBox, KVM, VMware workstations are example of your type 2 hypervisors which sits on top of your operating system, that is host operating system. For example, you have a machine SP laptop, on top of that you have some operating system, let's say Ubuntu, or let's say Windows, and on top of that you have one of these, and then on top of that you can have your own set of virtual machines.Maybe that can have a Windows operating system, that can have Linux operating system, any Linux operating system. And the feasibility what it gives is, like, you can, if you have some applications that is specific to a particular version of a particular operating system, this is the best place to actually this is how you can get the advantage of, and this is virtualization will help you in that case. So when talking about more about virtualizations and virtual machines, so virtualization is virtual machines is more over hardware level of virtualizations, where you are virtualizing your hardware. I mean, you're actually the hardware includes CPU, memory, NICs, and disk drives, and anything else than that. So on top of that, when you are actually having a hypervisor which will make those hardwares looks like a pool, and you can slice and dice those pool of a hardware into different partitions, so called virtual machines, right? So now going to the containers. So when you talk about containers are operating system level of virtualizations, while virtual machines were hardware level of virtualization. So in this, what we have is we have two fundamental concepts on top of which your container is built on. So they are cgroups and namespaces. So cgroups means grouping of a processes, limiting them and prioritizing them, and plus the namespaces. Namespaces is like a slice and dice the operating system and provides isolation. So the main purpose is you have an isolation which virtual machine does, and on top of that you impose a limit, this is what your containers are. And there are different types of namespaces: PID for process ID namespace, MNT for mount point namespace, net for network namespace, user for user namespaces, UTS for your hostname namespaces, and IPC for inter-process communication namespace. So as you can see, in this case, when you talk about virtual machines, right? So you have when you talk about type 2 hypervisors, there is one kernel within host operating system, and on top of that you have different virtual machines with a different kernel. But when you talk about this containers, you are virtualizing your kernel. So in this case, you have your kernel of your host operating system, and you're actually virtualizing it, and then you're using all the resources of an operating system. So PID, MNT, NET, user, and UTS, they are operating systems resources, and you are virtualizing them. But when you talk about virtual machines, you are actually virtualizing your hardware. So this is what virtual machines and containers are. There are so many other differences, so we cannot say like we used to say that containers are lightweight virtual machines. So they are not virtual machines. They are operating system level of virtualization, but yeah, they look like virtual machines because we have C groups and namespaces. The advantages of virtual machine is like when you have one hardware, and on top of that you can have different types of operating system. For example, you have you have a Linux operating system, Windows operating system on the same hardware when you impose virtual machines. But when you talk about containers, they are specific because they are bound to the kernel. So Linux containers or Linux operating systems can have only Linux flavors of operating system services on top of your containers, on top of your host. For example, if you want to have Windows containers, it is not possible to have Windows containers on top of your Linux based machines. Maybe it is possible if you have a virtual machine on top of that, like Docker desktop does it. So you have a Windows, on top of that you have a Docker desktop. What it does, it actually creates a virtual machine, and on top of it creates a Docker, and that is different scenario. Yeah. So this is what I think I wanted to understand. I wanted to explain what actually virtual machines and containers are. So these are a few basics. So thank you for watching, guys, and please subscribe to my channel and stay home, stay safe. Thank you.